Lesson 3.4, the quadratic formula. So the quadratic formula can be used to find the exact solution to any quadratic equation in the form of a times x squared plus b times x plus c equals 0. The solutions are given by this equation. So the quadratic formula is helpful to find these solutions, these roots, zeros, when normal factoring is not possible. So this will give us nice, typically it's going to be used when you have answers that will be decimals. So let's look at some examples. If you struggle with the quadratic formula, a suggestion I would make to you is to label out your A value, B value, and C value. So doing that, right, A value is always attached to the x squared, right? So this would have an A value of 1. It's going to have a B value of -8 and a C value of -33, right? So using that quadratic formula, let me just copy down the generic here. Right, so I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I'm just going to start substituting things in. Right? The biggest mistake here would be to miss a sign, not recognize a double negative, something like that. Right? So negative b, well, my b value is -8, so the opposite of -8 would just be 8. Plus or minus the square root of b squared, so -8 squared minus 4 times a times c. And then that is all going to be over 2 times my a value. So now I am just going to use order of operations to start working this through. So clean up the denominator since that's the easy part here. Right, 2 times 1 is 2. Working on the numerator, 8 plus or minus square root of. Well, I know -8 squared is 64. And then -4 times -4 times 1 times -33 is going to be a positive 132. Okay, so I'm going to move over here on my slide. I get x equals 8 plus or minus square root of 196. Right, I'm going to do the 64 plus the 132 all over 2. So x equals 8 plus or minus square root of 196, that's calculator work, is 14 over 2. So now I have to split, right? I'm going to have to split this into 2 problems. I'm going to have to go x equals 8 plus 14 over 2, and x equals 8 minus 14 over 2. 8 plus 14 is 22. Right? 22 divided by 2 is 11. And then 8 minus 14 is -6. -6 divided by 2 is -3. Right? So those are my 2 solutions. In reality, we could have factored this using normal trinomial factoring, but I wanted to give you an example that had nice whole number answers. So looking at example 2, it says here we're going to have some irrational roots, meaning we're not going to have nice, pretty whole numbers as solutions. So let's break this down. Right, I have an a value of 1. I have a b value of -6, and I have a c value of 2. Make sure that the right side is always equal to 0. That's the only time the quadratic formula will work, is when you have 0 equals or the quadratic equals 0. So x equals negative b. B is -6, so those two negatives are going to give me a +6, plus or minus the square root of b squared minus 4 times a times c. That's all going to be over 2 times a. So working to solve, starting to use some order of operations. -6 squared is 36. -4 times 1 times 2 is -8. So I'm going to have x equals 6 plus or minus square root of 28 all over 2. Okay, at this point, square root of 28 is irrational. So we are going to work to simplify this as far as we can. I recognize also that I am going to have to split this into 2 problems because of that plus or minus. Right, so this is going to be 6 plus square root of 28, and this side's going to be 6 minus the square root of 28. So let's take a look at square root of 28. Square root of 28 is not a perfect square, so I can do some factoring here on 28. 4 times 7. 4 is a perfect square, right? So square root of 28 would be square root of 4 times 7. Square root of 4 is 2. And then just square root of 7. Right? So there's my simplified form for square root of 28. To take this all the way to a finished answer, I can divide both of the numerator terms by the denominator of 2. Right, so 6 divided by 2 is 3, and 2 square roots of 7 divided by 2 is just square root of 7. Right, so that is your final answer. Some people would leave that as x equals 3 plus or minus square root of 7. Depending on the situation, you may need to work that out into decimal form, but either way. Another example on quadratic formula. Last example here, imaginary roots. So this one starting off is not equal to 0 on one side. So I can work to make that happen. I can subtract this 6x away. Right? So I get x squared minus 6x plus 13 equals 0. Once I do that, I know I have an a, a b, and a c equals 0, so I can use quadratic formula. So I get negative b. Well, my b value is -6. So opposite of -6 is 6. And then plus or minus square root of b squared. Well, my b value is -6, and that squared is 36. And then minus 4 times a times c, all over 2 times a. Well, a is 1, so 2 times 1 is just 2. So x equals 6 plus or minus square root of 36 minus 52. All over 2. Moving along, looking underneath that radical, 6 plus or minus square root of 36 minus 52 is negative 16. Okay, this is where we run into that imaginary. Simplifying square root of negative 16. Right? Well, that would be square root of negative 1 times 16. Square root of negative 1 is I, and square root of 16 is 4. So square root of negative 16 is 4i, or 4 times the imaginary. I can then divide both of those terms in the numerator by 2. So 6 divided by 2 is 3, plus or minus 4 divided, or 4i is divided by 2 is 2i. Right? So that imaginary number comes from having that negative under the square root sign. This should prep you out for lesson 3.4. Please reach out with any questions.